Good. All right, we left off on number 34.
Yep.
Let's have a look at 35. How do I find the maximum value of something?
The derivative and set it equal to 0.
Yeah. So what is y prime here? Your audio is breaking up a little bit, John. I don't know. Say something again. Count to 5.
1, 2, 3, 4, 5.
Okay. If it gets any worse, I'll have you sign off and sign back on again.
Okay.
But I think it's okay now. So,
Okay.
What's y prime?
Can we separate it into two fractions?
Well,
or no, we wouldn't want to.
You're only going to separate it into two fractions if your numerator is two terms.
Right.
In quotient rule.
Oh.
George, you're looking at a quotient.
My head was on integrals for some reason. Okay. So the derivative of the low d high, so x times 1 over x minus ln x times 1, so just minus ln x over x squared.
I think that's right, isn't it?
Yeah.
And I'm going to set that equal to 0, which means what?
Which means...
How do I solve that?
I'm not sure.
Well, when 0 is equal to a ratio, you can solve it with just normal algebra. Multiply both sides by x squared.
Okay. So then it would just be 0 equals 1 minus ln x.
Okay, so then what?
So then subtract 1, so then negative 1 equals negative ln x.
Better way to do that is to put the ln x on the other side, because then, then you're not dealing with negative signs.
Okay.
Okay.
So that's 1 equals ln x.
Okay, so what's x?
X would equal, well, you'd have to use e.
That's what x is equal to. In other words,
Yeah, so,
the natural log of e is 1.
Okay.
Okay, the other way to do it would be e to the 1 equals x. Just, I put the e, and I take that to that power, that's equal to the argument.
Okay.
Regardless, x is equal to e. So in that interval, the answer is what's e?
Well,
What's e?
E is 2.7.
With me?
Yeah.
What if they just said the interval from 3 to 5?
Well, then we'd have to, I'm not sure.
Okay. This is a possible question they're going to give you. In other words, if your horizontal tangent line does not fall in that interval, and we want to find out the maximum in that interval, then we find out, we plug in 3 for x, So y would equal the natural log of 3 divided by 3. And then we plug in 5 for x. Whichever number is bigger
is the maximum.
Is the maximum in that interval. The one thing that we know is there is no peak or trough. In other words, this interval, it has to either always be rising or always be falling, one or the other. So your maximum is going to come at an end point. If you do not have a horizontal tangent line in that interval, your maximum is going to be either a 3 or a 5.
Okay.
Okay. And you make these parentheses, now there is no maximum.
Okay.
Because if the maximum were at 5, what are you going to call it? 4.999999? So you have no maximum for those. Okay. Fundamental theorem of calculus. Whenever you see this expression, where you are taking the derivative of an integral, think fundamental theorem of calculus.
Okay. So that would mean it would be sine of 6x would be f of x.
Close. You do have to apply the chain rule.
So 6 sine of 6x?
Uh-huh. That's what f of x is equal to.
Okay.
Okay. The fact that that is a constant is the only thing that matters. It can be 1, it can be 4, it can be 1,000,000. As long as that is a constant, not a variable, then you're going to plug in that variable for t, and you're going to multiply it by the derivative of that variable.
Okay, and then since this is calculator, I would just plug in 0.12 x.
Yeah, in other words, we got 6 times sine of 0.6. So whatever that is, as long as you're in radians, always make sure you're in radians.
Right.
Which answer is not correct?
6.6.
Yeah, sine can never be greater than 1. And that would require it to be greater than 1. So I don't know what the answer is. Probably this, because yeah, it almost has to be. No, I'm sorry, I take that back. I was thinking the sine of 30 degrees was a half, and that's about a half, but I forget we're in radians. And when they give you radians and numbers, it's always kind of difficult to figure out what the trig functions are, unless you use a calculator.
Right.
Clearly want to do. Okay, let's look at second page. This is still from stuff you sent me last week. I did get the newer stuff though.
Okay.
Hold on, my thing's acting up a little bit. There we go. So we have the integral. Make sure I'm reading this correctly. Sine cubed of x, cosine squared of x.
Yes.
How are we going to do this?
Well, product rule. I'm doing the product rule, correct?
There is no product rule for integration.
Okay.
The product rule that you use for differentiation inverts to integration by parts.
Okay.
So the equivalent of the product rule is really integration by parts. But integration by parts is when you have two different types of functions being multiplied together. This is the same function. These are both trig functions. Can you make them?
Right.
In other words, this would be a whole lot easier if it was all in sine or all in cosine.
Right.
What's the one that can be converted the easiest?
Sine.
That's sine cubed.
Well, then probably.
What's the fundamental, the first fundamental trig identity, Pythagorean identity?
I need to brush up on those probably.
Definitely. For these tests, you've got to know your trig identities. Okay? In other words, they're not going to give it to you. What's that trig identity equal to?
Tangent squared?
Sine squared plus cosine squared. What's that equal to? That's the most important one you want to know, right there.
Just equals 1?
Uh-huh. No matter what x is. X can be 30 degrees, x can be 29 degrees, x can be 110 degrees.
It's just 1.
It's always equal to 1. Therefore, what's cosine equal to? Cosine squared.
1/2. Oh, 1 minus.
Okay. This is the one we want to use because we can turn cosine squared into 1 minus sine squared. So now we have the integral of
sine cubed of x times 1 minus sine squared of x.
Okay, now what are we going to do?
Well, we could factor out a sine squared.
I think it's already factored, or the sine cubed is already factored out.
Well, can we pull out another sine?
No.
Okay.
What can we do? There's only one thing left to do. Can't factor anything, but what can we do?
We can distribute.
Okay. And the advantage of distributing is, notice we have the product of that times that. It's hard to do products.
Right.
But once you distribute it, now you have two different things.
Oh, okay, I get it.
Okay. In other words, if you can turn products into sums or differences, that's the whole reason we have infinite series. Because you're taking a function that's difficult to integrate and you're turning it into a bunch of things being added or subtracted. And once you have a bunch of things being added or subtracted, you can integrate each thing.
Right.
It's the same thing. What's the integral?
Okay.
Sine cubed x. Take a look at the answers if you have any question about how to integrate that.
Well, you increase the power by 1.
First of all, let's talk about just doing this. Okay? How do we do that? What would you think? Especially based on those answers.
Well, it would just be cosine squared x.
What? Cosine cubed x. Hold on a second.
Over 3.
Hold on. It's cosine squared of x. Is it 3? Yeah, it is 3. Now, how can we prove that that's the integral?
Well, we'll take the derivative.
Okay. This actually requires u substitution. So let's go back here for a moment. I want to make sure you understand this. If I am differentiating that What is u?
U equals x?
No.
Sine x.
Right. Which makes this u squared. What's the derivative of u squared?
The derivative of u squared is 2u.
Times du dx. What's du dx? In other words, I didn't write it, but du dx is cosine x.
Right.
So it's u squared, the derivative of u squared is 2u times cosine x. So
right.
2 sine x cosine x would be the derivative of that. Yeah, I think I got off track here a little bit. It is important to notice that, what I just wrote.
Well, I thought u substitution was only used for integration.
No, it's used for differentiation when you have to apply the chain rule. See, this is the difficulty. U is different for this. In other words, up here, u is sine x because I know how to differentiate u squared. It's the derivative of u squared times du dx. Chain rule. Derivative of the outside times the derivative of the inside. Well, in this problem here, what is u?
U would be x squared.
Aha, totally different. Now I'm differentiating the derivative of u, which is the cosine of u times 2x du dx. So the differentiation process does use u substitution. It's just not normally called u substitution when you're doing differentiation. They call it the chain rule. And they say take the derivative of the outside times the derivative of the inside.
Right.
Okay. For integration, remember once when I asked you, had you been taught how to do these problems? In other words, there are 2 or 3 pages in the book on how to do those problems regardless of what n and m are. I think they may need to be integers.
I don't think we didn't really go over that, I don't think.
Okay. All right. Well, then let's go back and just do it the best way we can do it. So we're definitely at this step here. Okay. So looking at the answers, take a guess on what this integral is.
I would guess B.
Okay, so negative cosine cubed of x over 3. Let's differentiate that and see if we get sine cubed of x.
Okay, so then, well, what I usually do when I'm differentiating cosine and sine is I pull the 3 out, so I put it in parentheses, so it like makes sense.
Okay, so let's pull a negative 1/3 out.
Okay.
It's the derivative of the outside.
The derivative of the outside would be 3 -1 times cosine x squared.
No, it'd be cosine squared of x.
Oh, yeah.
Times the derivative of the inside. What's the derivative of the inside?
Times negative sine x.
something I'm doing wrong here. You know what? Let's table this until I can review those 3 pages.
Okay.
Integrating trig functions is a lot harder than it looks. I thought it might be this simple, but clearly it isn't. Because when we take the derivative of that, we get this over here. We don't get 9 cubed. So the problem is every single one of those answers looks similar. It's possible that cosine factors out. I don't know. But rather than waste your time in real time with me figuring it out, let me just, it'll take me 10 minutes, and the next time we have a session, I'll cover this problem.
Okay.
Okay? And
that'll be tomorrow night, probably.
Okay. I'll be ready by then.
Okay.
That's actually a very key step in integral calculus, is figuring out how to handle sine to the m, cosine to the n.
Okay.
And the reason is that you frequently come across polynomials that are extremely difficult to integrate. So what you do is you convert them to trig functions. And you end up with either tangent secant or sine cosine. And so if you know how to integrate sine cosine, then you go ahead and integrate it. Then you reconvert it to a polynomial. So you end up with the polynomial that's the integral. It's just you use trig along the way, because it's easier to integrate trig functions than it is polynomial functions. That's the bottom line. Okay, so here, what's the average value function? Or what's the average value general function?
So that'd be f of b minus f of a over b minus a.
Yeah, it's basically 1 over b minus a times the integral from b to a of f of x. And that makes sense. If you think of that as being the entire area, well, the average value would be a line. You know, if I had a function that was like this, and I wanted the average value between there and there, it makes sense to take the whole area, divide it by the difference between b and a, and you get something like that.
Right.
That's the average value of that function.
Okay.
So let's do that here. So we got 1 over what?
1 over 5 minus 1 is 1 over 4.
Times the integral of cosine of 2x. Now, this is easy to integrate.
Right.
What's the integral of cosine of 2x?
The negative sine of 2x times 1/2.
Divided by 2. The way I like to look at it is I always like to divide by the derivative of the inside.
Okay.
Now I want you to take the derivative of that and see if you did it right.
Okay, so then the derivative of that,
and that's probably not a bad idea whenever you're taking these tests, especially when it's easy to do. It's not going to take you 2 minutes to take the derivative of that.
Right. It'll be, so then take the derivative, and it'll be positive cosine 2x.
Hold on. What's the derivative of sine?
Derivative of sine is cosine.
So it's negative cosine of 2x times
2.
Gets rid of that. We almost did it right. What did we do wrong? In other words, that's not right. Its derivative does not produce what we started with.
Well, the negative sign, we're taking the derivative of negative sign, so that would be...
Still
negative cosine.
The derivative of sine is cosine. The derivative of cosine is negative sine. So the mistake you made when you integrated cosine is not negative sine, it's positive sine.
Oh, okay.
Okay. Very, very easy to make that mistake. Almost all my students get it mixed up, especially when they're going, you know, when you're learning both differentiation and integration. It's tough to figure it out. So that's the integral. Now, if I were to take the derivative of that, the derivative of sine is cosine, multiplied by the derivative of the inside is 2. I get cosine 2x. That's what I started with.
Right.
Indeed, we've done it correct. We can be certain of that at this point.
Right.
I'm evaluating that from 1 to 5, and I'm going to multiply it by 1/4. This part right here.
Right. So that's sine of 10 over 2 minus sine of 2 over 2. And that would be calculator.
Right.
So
let's stop right there because I don't think we need to go any further. Don't forget that 1/4. That's the
right.
1 minus a. Okay. And your calculator will give you this number. And no, there is no simplification that you can do right there.
Right.
Because that is in radians, and that is the number 2. Okay. I don't know what that is. I don't even know whether it's positive or negative. But that's a calculator problem at this point. Want to do 39 or save it to tomorrow night?
Let's just do it real quick.
Okay.
So R be the region between y equals e to the negative x squared power and the x-axis from 0 to 2. Find the volume of the solid when revolved around the x-axis. So we're integrating from 0 to 2.
Okay.
And it is 1/2. Or no, it's pi times the integral of 0 to 2 e to the negative x squared dx.
Okay, I'm going to take my pi and put it out front because it's a constant.
Right, and then wouldn't it be squared on the inside too? Like all squared?
Yes, it's pi r squared, and r is y. In other words, if I graph this function, I don't think it looks like that, but if it looks like that, that's r. In other words, I'm going to use disks to find this solid, and the radius of each disk is y. The disk I'm using over here has a higher y, and y is e to the minus x squared dx. Now, what is famous about that function?
I'm not sure.
Does not have an antiderivative. This is the most common example given where you have to use infinite sums. You have to use the Taylor polynomials for e to the minus x squared to solve this. There's no function whose derivative is e to the minus x squared.
Okay.
So the only way to integrate this is by using those power functions. Your calculator will do it. You can get this out of your calculator.
Right, it's a calculator question.
There's no way to do it manually finding an antiderivative.
Okay.
Okay. So next time we'll redo 37.
Right.
And then start with the next one after 39.
Okay.
Okay, John? All right. Have a good day. I'll talk to you tomorrow.
Okay.
Bye-bye.
Bye.